Hello friends, uh, here I am starting one new channel. Its name is Design It All, and this channel is to share some of my engineering experience earned while working in different industries. Viewers may agree or disagree with my methods of working, but it is up to them whether to follow them or not. This channel is to make your day-to-day engineering practices easier. So we shall start with the video. I am here going to show you to make a cam with an example from this SS Ratan Theory of Machines book from 7.4 example. I am taking this one. In this example we are having the input data with us. We are going to draw only a profile in this video. We are not much interested in what are the speeds and what the accelerations and any other informations that is solved in this example. We are dealing only with the construction part, that is the drawing of this cam. So to start with this, we have the input data as draw the profile of the cam operating a roller reciprocating follower and with the following data. Minimum radius of the cam is 25 mm. I had developed one Excel sheet for this drawing this profile, and this Excel sheet you can find this on a link given in the description of this video, so you can directly download from that on the Google Drive, from the Google Drive link that I had shared to you. So with this Excel sheet we will draw the cam. So with this we have the minimum radius of the cam, that is this one. The minimum radius of the cam is 25 mm. So in the Excel sheet we have this one radius starting of center of roller. Actually this is the minimum radius plus the roller diameter, so it is 25 mm plus the roller diameter, that is 15 mm, and this will be 25 radius plus 7.5 is the radius of the roller, so it will be 32.5. so we have put here 32.5. so actually this example, in this example there is 120 degree of the cam lift with SHM followed by a dwell period of 30 degrees. Then the follower lowers down during 150 degree of cam rotation with uniform acceleration and deceleration followed by a dwell period. So with the SHM motion cam, this sheet is for SHM motion, this one is for constant acceleration and deceleration, this one is for velocity, constant velocity, and the other is the cycloidal follower with the cycloidal motion. So with this sheet we are going to use only these two sheets for this example, SHM follower and constant acceleration and deceleration. So with this we have 120 degree of SHM motion with the SHM motion. The cam lifts the follower. So in this sheet 120 degree is for this SHM motion, so this column is phi, angle phi. You can get the data from this the notations, explanation for this notation from the same chapter which I had also placed on the drive link. Google link, so you can get the know the what is theta and phi and all this from this book. It is all mentioned in this chapter. So 120 degree is this, in this column I had placed this 120 degree, and the smallest for theta angle for different from 0 to 120 degree, this is the angle theta, and minimum smallest division I had kept is as 0.5 sorry 5 degrees. So it is incremented by 5. This is 5, 10, 15, 20 like this up to 120. Then the lift of this cam is 30 mm, so the lift h is defined in this column. This is 30. Then the angle beta is calculated. These yellow cells shows that these are these are formula based columns, so do not directly add any inputs. You have to add in this white cells, you can add the inputs only. So these cells will you don't have to put any values in this in these cells, just only you have to stretch it down. Okay, so these yellow cells has to be stretched down, not the white cells. This one, the white cells are editable and yellow cells are formula based, right? So this beta, you can we have this formula. With this formula we have this value, the last value should be pi, in order to check if you are correct or not in this in this calculating. This value should be pi, the last value. This, then s is the displacement. So this displacement is same as the maximum, the last value will be same as that of the lift h. So this is stretched directly from top to bottom. This is formula, the same formula is in the every cell. So then this 32.5 it is the roller diameter, the roller pitch radius of the center, radius for starting of center of the roller. So we are actually going to draw this roller center profile, this one, 1 dash, 2 dash, 3 dash, 4 dash, and so on, like this. So this is the RCR, and this one is the RS. This is the actually the this is the roller center, and this one RS is the radius from center to the pitch of the roller center, pitch line of the roller center. So with this we have RS. It is also formula based, it is stretched from top to bottom here, and this value is this is roller center plus lift, that will be 32.5 plus this 30, it will be 62.5. so these are the summation of these two columns. So with this, first 120 degrees is the SHM motion from here to here. So we will pick this column, copy, paste it over here, values only, again Control C, and put it in the curve. This sheet we are going to have the cam angle, and this RS radius, this is the radius of circle of harmonic curve at angle theta. So I will paste it over here, paste values. So I am going to place only the values. So from this 0 to 120 degrees I have reached over here. Okay, these are the x and y coordinates of the system. So I will just take up to 360 degree. I had taken this, and I will draw an smooth curve profile of this. So actually I will put it over, just a minute, at the top. Actually this is coming to 0 because we have not filled the remaining cells. So the next is the dwell period for how much, 30 degrees, theta 1 and delta 1. So remaining 30 degrees, that is from 120 to 150, we are having the same dwell period. So I will stretch the same RS radius over here, and after that we have the constant uniform acceleration and deceleration, and this is actually the follower lowers down during this 150 degree of cam rotation. So for this we will follow the another sheet. This is the constant acceleration and deceleration. So similarly in this also, for 150 degrees, this is phi angle up to 150 degree, and with the incremental of 5 degrees we have the theta angle from 0 to 150 degrees. This is the again lift h, and here this is the formula based. Actually you have to study this properly. Okay, so this is first 50% of the curve is an acceleration curve, and the remaining 60% is a deceleration curve. So this is split, this 150 degree of angle is split into 75, and the remaining 75 is percent is remaining 75 degrees is split in for the deceleration, and this is the square of the this one cell. So up to this 75 degrees, it is same formula is over here in this column. So this is not going to change, but this is going to change. This color is different from here. It is from, this is from 0 to 1 2 to 5 square of the first column. This is serial number, and the another, this one is reverse from, this is 90 196 169, the reverse way. So it is going to be over here. So this is formula for calculating the displacement, and you have displacement from 0 to 30. So this is the displacement which is in ascending order. We need to make it a descending curve. So we will have this value as RS. So this is this column I will take, and up to this copy and paste it over here, values only. This will, I will delete it. This is, we need to arrange in a descending order. So from 1 to, so I need to make it a descending order. Sort, custom, values in C from largest to smallest. Okay, so this is the descending. This 62.5 we had already taken in the chart of this. It is up to 150, it is going to be 62.5, and from 155 degree it is going to descend. So we shall take the next value from here, that is means from here to the last one, this one. Control C, and I will paste it in over here, paste it. Okay, up to 300 degrees we have reached. So 150 we had uh, after the dwell period we have, and a descending, in this descending form we have the uniform acceleration and deceleration in this 150 degree. Then the remaining period is again a dwell period, which is of 60 degrees, delta 2. So we will continue this value up to end. Save. So now our curve is completed over here. So this is our actually the cam profile. So we have this excel x and y coordinates of the cam profile. We will take it, control C, and put it in a new text document, sorry, in the notepad. This is the notepad file, and I will paste it over here. So these are the values. Just a minute, I need to place one more column for Z coordinates also. Just a minute. Control C, I will put this in a new sheet. Paste the values, and the other column for 0, the Z coordinate. Now we are going to place it, copy this, control C, and paste it in new document. This it Arial font, Arial. Okay, this looks better. So I will save this and rename it as points for curve. Okay, I will put this, call this points in the new file in Solidworks. This is the part, new part. Okay, we have feature here, curve through XYZ points. I will browse this file, take from desktop this file, text file, points for cam curve, open, and this unit is inches. Sorry, I need to convert it into mm. Metric, again curve through points, browse, text file, points for cam, open. So this is the curve that we have got. So okay with this, this is the cam curve. Now this profile is a profile of the path of roller that is traced throughout this 360-degree. Actually it is in this, with that this you can see in this diagram also, the same profile. So this profile, it is, we have drawn this 1 dash 2 dash 3 dash, likewise here this is that profile. We need to offset this profile to make our actual cam profile. So I will draw one sketch, another sketch, this, okay, offset it, offset this curve by roller radius, it is 7.5 mm. So this I will put 7.5 mm, and it is inside, okay, okay, this I will hide it, and this profile I can extrude it. So this we have drawn a cam profile. Example 7.4. So we have drawn this cam. This is a complete smooth curve, and you can increase the accuracy or this of these points by making the smallest division to as low as you can make it, because I am in practice, I am doing up to 0.1 smallest division, so I need to take about 3600 points for this, completing this profile. It is a very accurate way to draw the profile. So this is what I follow in my practice for drawing such type of cams. For the other two motions, this constant velocity and the cycloidal, you can follow the similar steps. So it is very easy to do it through this Excel sheet, and I have placed this on the and shared this Excel sheet with you on the Google Drive. So I think this video will be helpful in making such type of cams. So thanks for watching this video.